Good morning, Year 6. So your work today is we are learning to use the 4 operations with decimal points. Now again, just like we've been doing the last week or so, this is a bit of a recap of previous learning. So we're going to be looking at addition, subtraction, multiplication and division, all with numbers that include a decimal point. And what's really crucial is that you remember that golden rule of decimals, something that I really tried to hammer into my class all through this year, is that the decimal points must be lined up. And by lined up I mean one on top of another, like this, or in some cases 3 of them, like that, one on top of another. That's what I mean by that, and we're going to explain why that is the case now. So I've got a very simple place value grid or a place value chart here: thousands, hundreds, tens and ones. Now if I asked you to add this number and that number together, 3,217 add 631. Now when you do this, you know how important it is that these numbers get lined up correctly. So this 6 would go under the 2, the 3 would go there, and the 1 would go there. And we could begin to add them up. And there wouldn't be anything here. The reason why this number, 631, there is nothing in this thousands column. And if I was to put this into this place value chart here, and put this underneath, that's why, because we've got, in this first number here, there are 7 ones, aren't there? There's 110, there are 2 hundreds, and there are 3 thousands. This number underneath, there's 1 in the ones column, there are 3 tens, and there are 6 hundreds. That's why we've lined them up, because when I come to add these, I'm adding the ones, I'm adding the same unit, aren't I? I'm adding 7 ones and 1 1 to get to 8. Then I'm adding 4 tens and 1 10 to get to 4 or 40. Then I'm adding 600 and 200s to get to 8 or 800s. I'm adding 3,000 and there's nothing here, so that's why it's just 3,000. So it's absolutely crucial that everything gets lined up, and it's exactly the same with a decimal number. If I were to rub these off and to just draw now a couple of extras in here. So in here, this is the tenths, and the tenths, and then the hundredths in there, and the decimal point will go here, won't it? Now everything to the right of the decimal point is these are all smaller than 1, aren't they? So if I was to have this number now, sorry, make sure that 8 is clear, that's an 8 plus 3.2, so I've got 31.87 at 3.2. Now I was to write that in here, 31.87 add 3.2. I'm not going to put the 3 here because it's 3.2. There's just 3 ones, aren't they? 3.2. So that shows that's why we line them up, because in this first number there are 7 hundredths, but in 3.2 there are no hundredths in here. That's why it's got to be lined up. There are 8 tenths and 2 tenths. There's 1 and 3, and then there are 3 tens. So that's why if we line it up, so I put the decimal point underneath, 3.2, and then add them like this. Now, if you want to, you can put in some plugs, as I remember Ruby Wilson in my class called them that, plug in the gaps with zeros. I quite liked that wording. You can put them in there. So 7 add 0 is 7. 8 add 2, remember this is 8 tenths add 2 tenths, so 8 tenths add 2 tenths is 10. That's why it goes over to there, because it's gone into the ones, hasn't it? And then 3 add 1 is 5, 3 add nothing is 3. So at the moment we've got our answer as 3,507. Clearly wrong, because these need to be lined up like this. Okay, decimal points, one on top of another. Okay, because we've added these all up, haven't we? This number here, 31.87, is very close to 32, isn't it? 32 add 3 is 35. So you see our answer looks sensible, doesn't it? 35.0. So it's absolutely crucial you do that. Now, I'm just going to show you what would have happened if I didn't line up those decimal points. If I just put 3.2 here and lined them up on the left hand side. So even if I do all my calculations correct, 7 and nothing is 7, 8 and nothing is 8, and then if we add these up, so we've got as our answer is 6,387. We've got, where do we put the decimal point? Do I line it up with this one to get to 63.87? It's still wrong. Or do I put it here, 6.387? It's still wrong. It doesn't matter where you put it in this calculation, it's wrong. Even though all the additions are correct, they weren't lined up in the first place, so we've gone wrong. Just like is if we were to have lined it up over on the right hand side, which is a mistake that I see probably more than the one we've just done. So again, I'll do all the calculations correct and just show you how wrong the answer is. So 7 and 2 is 9, 8 and 3 is 11, 1 and 1 is 2, 3 there, and then where do we put the decimal point, because they're in two different places. If I line it up with this one, put it here, we get to an answer of 321.9, or if I line it up with here, we get to an answer of 32.19, again, which is incorrect. So it's absolutely crucial you do it like I've shown you here, with those decimal points all being lined up, because it proves it here on the place value grid why we need to do that. So we're adding the correct unit, we're adding the hundredths together, we're adding the tenths, we're adding the ones, the tens, and so on. That's why it's crucial that they get lined up. So that's an addition. I'm going to write an addition for you now, year 6, just for you to have a go at. Okay, so let's have a go at 6.783 and 42.6. So could you have a go at that for me, year 6? Maybe pause the video there, have a go at this, and then unpause it to see if you get it right. Right, so let's begin to write this out now. It's usually good practice when you are adding to put the larger number first, and 42 is larger than 6, so let's put 42 on top, lining up that decimal point. So the decimal point is going to be here, isn't it, directly underneath. We can't change that, so let's put this number 6.783 around the decimal point. So the 6 will come here, won't it, in that ones column. The 7 is in the tenths, 8 and then 3. Now we can see here we've got 1, 2, 3 spaces in our place value chart here, so if we wish we can put a 0 in there, because in this number there are no hundredths, and in this number there are no thousandths either, and if we wish we can put one here as well, because there are no tens in that number, and then it just becomes like a straightforward column addition. So this is 3 and then 8 and 7 and 6 is 13, the 3 goes there, the 1 comes over here. Remember, it doesn't go above the decimal point, it goes over the ones column. The decimal point isn't actually a column in the place value chart, it separates the ones and the tenths. And then 6 add 2 add 1 is 9, and then the 4 goes there. We're not finished yet, decimal point goes in. Remember, you can put the decimal point in at the start if you want, before you even do your additions. You can put it in as you work your way along. You could do it here in between these numbers, or you could do it at the end. As long as you remember to put it in, it doesn't matter when you do it. So the answer to this one, 49.383. And if we look at the original numbers, it looks correct, doesn't it? 42, a number that is larger than 42, a number that's larger than 6. 42 add 6 is 48, so it looks like a sensible answer, doesn't it? Which is really important. So that's addition. Now subtraction is exactly the same. That golden rule of decimals again. So let's have a go at this one. 17.8 subtract 3.83. Now it's always a good idea to have a rough estimate of what you think the answer is going to be. So this number is quite close to 19, isn't it? This number is quite close to 4. So 19 take away 4 is 15. So ideally our answer should be somewhere around 15. So it's not going to be exactly 15 because we're not working with whole numbers, we're not working with integers here, we're working with numbers with decimal places. But our answer should be close-ish to 15. So again, let's line them up. So 18.7, and when you're doing a subtraction, this number has to go, the first number has to go on top. Subtract 3.83, golden rule of decimals, line up the decimal. So 3 will go there, 8, 3. You can see here, can't we? We can plug these gaps with zeros. So 0 take away 3, we can't do that, so we need to exchange. That 7 becomes 6, and the 1 comes over there to turn it into 10. 10 take away 3 is 7. We can't do 6 take away 8, so again we exchange. That 8 becomes 7, this becomes 16. 16 take away 8 is 8. I'll put the decimal point in now as I go. 7 take away 3 is 4. 1 take away nothing is 1 to get us around to 14.87. And we can see 14.87 is very close to 15, isn't it? So it looks like a sensible answer. So it's a good idea to have an estimation before you actually do this. So I'll write one out year 6 for you to have a go at. So 49.7 subtract 8.63. You pause the video there, year 6, have a go at that question, then unpause it and you'll see if you get it right. So again, let's line them up. 49.7 subtract, put the decimal point in first, and you see that the 8 goes to the left of it, and the 6 and the 3, taking real care to line up those numbers. Plug with zeros again. 0 take away 3, we can't do that. So that 7 becomes 6, this becomes 10. 10 take away 3 is 7. 6 take away nothing. 6 take away 6 is nothing. 9 take away 8 is 1. 4 take away nothing is 4. And again, decimal point lined up there. You can see it looks like a sensible answer again, doesn't it? This number is very close to 50. This number is very close to 9. So 50 take away 9 is 41. You can see our answer is very close to 41, so it looks like a sensible answer. Okay, so we've looked at addition, we've looked at subtraction. Now let's have a look at some multiplication. So I will do one first of all for you. So let's have a look at 17.63 times by 5. Let's have a look at that. Right. Now again, the decimal point is here, so our answer is going to have a decimal point here. This has got 2 decimal places, so our answer is going to have 2 decimal places. The reason why that is, we're going to be multiplying each of these numbers by 5. So we're doing 5 times by 3, but really we're doing 5 times by 3 hundredths. So that's why our answer will come here. Then we'll do 5 times by 6, but really we're doing 5 times by 6 tenths, which will come here. Then we'll do 5 times by 7, which actually is 5 times by 7, then 5 times by 1, which is really 5 times by 10. So let's do 5 times by 3, which is 15. 1 gets carried over there. 5 times by 6, which is 30, add 1 is 31. 5 times by 7, which is 35, add on 3 is 38. 5 times by 1 is 5, add the 1 is 8. To get to our answer of 88.15. And again, if I haven't put that decimal point in, look how wrong my answer is. 8,815. Completely wrong. It's got to be here lined up. Just like if even if you put it in the wrong place, here you can see it's not lined up. Incorrect answer. Just like if it was here, incorrect answer again. It's got to be lined up like that. So I will write one for you to have a go at year 6. Let's have a go at 83.87. Let's do one going into the thousands times by 3. Okay, remember where that decimal point is going to go. So pause the video, have a go at that year 6, then unpause the video to see how you did. Okay, so first of all, we're going to multiply 3 by all of these numbers, aren't we? 3 times by 3, but really it's 3 times by 3 thousandths, isn't it? It's quite complex saying that, so we just say 3 times by 3. 3 times by 3 is 9. 3 times by 7 is 21. The 1 goes there, the 2 gets bumped over to the next column. 3 times by 8 is 24. Add the 2 is 26. So the 6 goes there, the 2 over in the next column. Remember, not above the decimal point, over on the 1, the 1's column. 3 times by 3 is 9. Add 2 is 11. 3 times by 8 is 24. Add 1 is 25. That decimal point gets lined up. There are 3 numbers after the decimal point, so there needs to be 3 numbers after the decimal point here. There we go, gets lined up there. 251.619. And again, it looks like a sensible answer, doesn't it? Because this number is very close to 80. We could do 8 times by 3, which is 24. Add that 0 back on, is 240. And we can see with this extra portion of the number, the answer is going to be slightly larger than 240, which this is. So again, it looks sensible. Okay, so the final one we're going to look at today, doing a whistle-stop tour of decimals. We've looked at addition, subtraction, multiplication, and you guessed it, we're going to look at division now, and it's exactly the same. The golden rule of decimals: line those decimals up. So let's have a go at, let's go with point. So 21.56 divided by 7. So this number is going to get split equally 7 times. Decimal point is here, so our answer needs to have the decimal point directly above it. Not here, or at the end, or not there at all. It's got to be directly above it. Our answer has got 2 numbers after the decimal point. Our question has got 2 numbers after the decimal point, so our answer needs 2 as well. But it's just like a normal decimal. A normal division question. How many times does 7 go into 2? It doesn't. And carry the 2 over. How many times does 7 go into 21? It goes in 3 times. There's nothing left over. How many times does 7 go into 5? It doesn't. You can carry that 5 over. How many times does 7 go into 56? It goes in 8 times. So there's our answer, 3.08. You see what an accurate answer you've got there. It's like a calculator, isn't it? But just remembering to put in that decimal point directly above it, just like we've looked at with the other operations. So, last question for this video for you to have a go at, and we will do a slightly larger one, and we'll divide it by 5. Let's do... do a longer one. You're capable of that. So 318.755 divided by 5. Could you have a go at that for me, year 6? Right, so how many times does 5 go into 3? It doesn't. And the 3 gets carried over. How many times does 5 then go into 31? It goes in 6 times. With 1 left. How many times does 5 go into 18? It goes in 3 times with 3 left. Remember, we've just gone past the decimal point now, but it doesn't matter. How many times does 5 then go into 37? So that goes in 7 times with 2 left. How many times does 5 go into 25? Well, it goes in 5 times with nothing left. How many times does 5 go into 5? It goes in once. We're not finished yet. What have I forgotten? Hopefully you've realised decimal point, otherwise my answer is far, far too large. So the answer gets to 63.751. So hopefully year 6 you've understood what we've done there. It has just been a recap again of things that we have done before we are all back in school next week and able to do maths together in our classroom. But the things that we've done today are really important for you to know in your maths education and just in general life. So I hope you have understood it. Thanks a lot.